Hello and welcome to another masterclass. If you are new to this channel, please click on the subscribe button below. Since new videos are being added to the channel regularly, click on the notification bell and you will be informed immediately whenever a new video is published. In this third lesson on trigonometry, we'll be learning about trigonometric ratios in the 30, 60, 90 triangle as well as the 45, 45, 90 triangle. We will also be learning about three trigonometric ratios, namely secant, cosecant and cotangent. Before we proceed, we will have a quick recap of what we have learned so far. So far we have learned about three trigonometric ratios. We have learned that in a right angle triangle, sine theta is equal to opposite side upon hypotenuse. Also, cos theta is equal to adjacent side upon hypotenuse. Tan theta on the other hand is equal to the opposite side divided by the adjacent side. We have also learned that sin theta is equal to cos of 90 minus theta and cos of theta is equal to sin of 90 minus theta. Also, sin theta divided by cos theta is equal to tan theta. In this lesson, we will now learn trigonometric ratios in standard right angle triangles, that is in the 30, 60 and 90 triangle as well as the 45, 45, 90 triangle. We will also be learning about three new trigonometric ratios, namely secant, cosecant and cotangent ratios. Let's begin with the 30, 60, 90 triangle. We will first recall the 30, 60, 90 theorem. The 30, 60, 90 theorem states that in a triangle whose angles measure 30 degrees, 60 degrees and 90 degrees, the side opposite the 30-degree angle is half the hypotenuse and the side opposite the 60-degree angle is root 3 upon 2 times the hypotenuse. This means that if the hypotenuse of the 30, 60, 90 triangle measures x, then the side opposite the 30-degree angle is half x and the side opposite the 60-degree angle is root 3 upon 2 times x. Using this theorem, we can now calculate the sine, cosine and tan ratios of the 30 and 60-degree angles. So sine of 30 is equal to opposite side upon hypotenuse. And if we observe the figure, we will note that sine 30 is equal to BC upon AC. Sine 30 therefore is equal to half of x divided by x. Or in other words, sine 30 is equal to 1 upon 2. Similarly, we can show that sine 60 is equal to opposite side upon hypotenuse, which is equal to AB upon AC. And since the side opposite 60 degree is root 3 upon 2 times the hypotenuse, sine 60 is equal to root 3 upon 2 times x divided by x. Sine 60 therefore works out to be root 3 upon 2. We can also show that cos 30 is equal to adjacent side upon hypotenuse, or cos 30 is equal to AB upon AC. Therefore, cos 30 is equal to root 3 upon 2 times x divided by x, and cos 30 works out to be root 3 upon 2. In a similar way, we can show that cos 60 is equal to adjacent side upon hypotenuse. Therefore, cos 60 is equal to BC upon AC, and cos 60 now works out to be half x divided by x. Cos 60 works out to be 1 upon 2. We will now calculate the tan ratios. Tan 30 is equal to opposite side upon adjacent side. Therefore, tan 30 is equal to BC upon AB, that is equal to half x divided by root 3 upon 2 times x. So tan 30 works out to be 1 upon root 3. Similarly, we will now calculate tan 60. Tan 60 is equal to opposite side divided by adjacent side, that is equal to AB upon BC. So tan 60 is root 3 upon 2 times x divided by 1 upon 2 times x. this works out to be root 3. Therefore, tan 60 is equal to root 3. We will now study the 45-90 triangle. We will first recall the 45-90 theorem, which tells us that in a triangle whose angles measure 45 degrees, 45 degrees and 90 degrees, the hypotenuse is root 2 times each of the sides opposite the 45-degree angle. Therefore, in a triangle whose angles measure 45 degrees and 90 degrees, if the sides opposite the 45-degree angle measures x, then the hypotenuse measures root 2 times x. Using this theorem, we can calculate the sine, cosine and tan ratios of 45-degree angle. First, we will calculate the sine of 45. Sine 45 is equal to opposite side divided by hypotenuse. Sine 45 therefore is equal to AB upon AC. Sine 45 works out to be x divided by root 2 times x, or sine 45 is equal to 1 upon root 2. Similarly, cos of 45 can be calculated as follows. Cos 45 is equal to adjacent side divided by hypotenuse, which is equal to BC upon AC, which is equal to x upon root 2 times x. Therefore, cos 45 works out to be 1 upon root 2. Tan of 45 can also be calculated as follows. Tan 45 is equal to opposite side divided by adjacent side. Tan 45 therefore is equal to AB upon BC, which works out to be x divided by x. Therefore, tan 45 is 1. It will be seen that as one of the acute angles becomes closer and closer to 0, the other will become larger and comes close to 90 degrees. As a result, the side opposite the very small angle will become very small in length, almost equal to 0. Also, the side opposite the larger angle will become larger in length and it will become almost equal to the hypotenuse. From this, we can calculate trigonometric ratios, namely sine, cos and tan of 0 degrees as well as 90 degrees. So we get sine of 0 is 0, cos of 0 is 1 and tan of 0 is 0. On the other hand, sine of 90 degrees is 1, cos of 90 degrees is 0 and tan of 90 degrees is not defined as the number becomes very large. We now learn some additional trigonometric ratios, namely secant, cosecant and cotangent ratios. We first begin with the secant ratio. Let theta be one of the angles of a right angle triangle, triangle ABC, and let theta be equal to angle ACB. Sec theta therefore is equal to hypotenuse upon adjacent side. Sec theta is equal to AC upon BC. You will recall that cos theta is equal to adjacent side upon hypotenuse, and we have just learned that secant theta is equal to hypotenuse upon adjacent side. Therefore, it will be seen that cos theta is equal to 1 upon sec theta, or sec theta is equal to 1 upon cos theta. We will note here that secant has been abbreviated as sec. Cosecant ratio. Let theta be one of the angles of a right angle triangle, triangle ABC. Let theta be equal to angle ACB. Cosec theta therefore is defined as hypotenuse upon opposite side, or cosec theta is equal to AC upon AB. You will recall that sin theta is equal to opposite side upon hypotenuse and cosecant theta is equal to hypotenuse upon opposite side. Therefore, it will be seen that sin theta is equal to 1 upon cosec theta and cosec theta is equal to 1 upon sin theta. You will also note that cosecant has been abbreviated as cosec. We now come to cotangent ratio. Let theta be one of the angles of a right angle triangle, triangle ABC. Theta is equal to angle ACB. Cot theta therefore is equal to adjacent side divided by opposite side. or cot theta is equal to BC upon AB. You will recall that tan theta is equal to opposite side upon adjacent side, and cot theta is equal to adjacent side divided by opposite side. Therefore, it will be seen that tan theta is equal to 1 upon cot theta, and also that cot theta is equal to 1 upon tan theta. Note that cotangent has been abbreviated as cot. We have now come to the end of this lesson. Let's have a quick look at the trigonometric ratios of the standard angles, namely 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. We'll note that sine 0 is 0, cos 0 is 1 and tan 0 is 0. Sine 30 on the other hand is 1 upon 2, whereas cos 30 is root 3 upon 2 and tan 30 is 1 upon root 3. Sine 45 is equal to 1 upon root 2 and cos 45 is also 1 upon root 2. This means that tan of 45 will be 1. Sine of 60 degrees is equal to root 3 upon 2, whereas cos of 60 is equal to 1 upon 2. Tan 60 degrees is equal to root 3. Sine of 90 degrees is equal to 1, cos of 90 degrees is equal to 0, and tan of 90 degrees is not defined. In the next video, we'll learn how to solve some problems using trigonometric ratios of the standard angles. We'll also solve some problems using trigonometric identities. To visit the masterclass channel, click on the round logo. Don't forget to subscribe and also click on the bell to be notified immediately when a new video is uploaded. Thank you for watching this video.